We generate more digital information today than at any point in human history, yet the vast majority of this output never enters the public domain. Instead of the connected global network of knowledge, massive troves of valuable research and civic data remain locked away inside highly isolated institutional silos. The push to break down these walls started gaining traction between 1995 and 2007, coalescing around a single specific philosophy: the open data movement. The premise is straightforward. Digital data should be made freely available to the public, with absolutely zero restrictions on how it can be used, modified, or distributed. On paper, this philosophy has won. We see widespread policy buy-in across the globe, with municipalities and major intergovernmental bodies increasingly mandating that taxpayer-funded data must be shared openly. Simultaneously, large cultural and historical archives are undertaking the massive effort of transitioning centuries of physical records into accessible digital formats. To map out this new digital commons, institutions adopted a technical framework known as the FAIR principles. FAIR dictates that data must be findable, accessible, interoperable, and reusable. But there is a flaw in how we apply this framework. FAIR provides technical guidelines heavily designed to assist automated machine discovery. It is not an operational standard. By over-indexing on software architecture, we have largely ignored the severe human and economic friction that actively prevents institutions from sharing their work. Building the perfect database means nothing if the people generating the data are incentivized to hoard it. Until we resolve the socio-economic roadblocks keeping institutions siloed, a true digital commons will remain out of reach. This diagram outlines the spectrum of data rights, establishing the minimum technical and legal requirements for true openness. The global open definition requires complete dataset availability, universal participation, regardless of the user's field, and the explicit waiving of proprietary ownership through standardized licenses like CC0 or CC BY. This brings us to a crucial distinction. Much of what we consider open is actually just gratis data. It is provided at zero monetary cost, but it remains legally restricted. You can view it on a web page, but you cannot systematically scrape, parse, or republish it without violating terms of service. The ultimate standard is Libre data. This grants users the explicit legal permission to dismantle, transform, and even commercially monetize the underlying information. This strict Libre permission is the absolute prerequisite for linked open data, an architectural method where disparate computing systems automatically read semantic connections across the web without needing human permission at every step. Removing a paywall does not create a functional ecosystem. Without the explicit legal rights to parse and intermix information, the internet remains a collection of static, disconnected documents rather than an intelligent, automated network. Once a dataset clears the legal hurdles, it enters a strict three-step technical curation pipeline designed to ensure machines can actually read and utilize it over time. First, the data must be saved using non-proprietary encoding. It has to exist in open text formats like JSON or CSV, rather than being trapped inside proprietary corporate software files. Second, it requires persistent identifiers, such as DOIs. When a university or government agency inevitably updates its website architecture, these permanent digital links ensure that external discovery protocols do not break. Third, the file must be wrapped in comprehensive metadata. This provides external systems with the contextual provenance, field definitions, and domain-specific vocabulary they need to understand what they are analyzing. Those are the best practices. In reality, the data publishing pipeline routinely breaks down under the weight of human error and severe operational friction. The first point of failure is vocabulary friction.
If two different ecological repositories use conflicting terminology to describe the exact same variable, automated machine reading fails entirely. The second failure point is indexing deficits. Data buried deep within domain-specific institutional archives often lacks the correct structural visibility, effectively hiding it from search engine web crawlers. Finally, there is the crisis of quality certification. The massive, rapid ingestion of open civic data creates an overwhelming need for verification. Determining if an uploaded spreadsheet is methodologically sound still requires intense manual auditing by human workers. Technical perfection is an illusion here. Even perfectly formatted, machine-readable data provides zero utility if it cannot be structurally matched, located, or trusted without painstaking human intervention. But the most critical roadblock facing the open data ecosystem has nothing to do with software. The true barrier is the intense web of institutional disincentives surrounding its adoption. We are looking at a profound tug-of-war between competing interests. The macro-level benefits of a transparent data commons are constantly fighting against the micro-level risks assumed by the individual people and institutions producing that data. On the civic level, transparent data empowers citizens to audit government spending and public records. However, publishing this information creates severe vulnerabilities regarding the accidental de-anonymization of sensitive personal health or national security records. From an economic standpoint, free civic infrastructure allows startups to build highly valuable commercial tools, like live transit tracking. Conversely, private corporations lose their competitive moat and the ability to charge subscription fees for proprietary datasets. In academic research, taxpayer-funded studies yield data that inherently belongs to the public, enabling vital interdisciplinary replication. Yet researchers face the very real threat of being scooped. They are terrified to release raw experimental data before extracting their own publishable insights. Operationally, standardizing data allows different agencies to bypass redundant collection efforts. But cleaning, securing, and hosting petabytes of data incurs massive financial overhead for the host institution, generating absolutely zero direct monetary return. Guidelines do not pay cloud storage bills. They do not protect an ecologist from having their career stalled by a rival laboratory. As long as sharing this data remains a professional and financial liability, these closed silos will naturally persist. Academic and municipal networks have mistakenly treated technical guidelines as a complete operational strategy. We optimized the entire system for machine discovery while ignoring the human reality of the people doing the actual data production. To break the current deadlock, the open data ecosystem must evolve from a static publishing model into an iterative, collaborative value chain. Progress relies on three distinct structural evolutions. First, we need formalized data portability mandates. Regulatory frameworks must legally guarantee a researcher's right to package and transfer their data across competing host platforms without facing proprietary lock-in. Second, we require sustainable funding models. Government bodies and grant providers must stop treating massive data storage as an administrative afterthought and begin funding it as permanent core infrastructure. Third, repositories must embrace nuanced access tiers. To reconcile transparency with privacy concerns, sensitive metadata can remain publicly searchable, while raw file downloads are strictly gated to authenticated, ethically bound actors. The premise that information grows in value when shared is correct, but we will only achieve a true digital commons when we stop merely standardizing file formats and start actively realigning the economic incentives of the institutions doing the work.